Welcome guys to my channel, the Electrocoder, where electricity meets code. Today we are going to make the project on single phase inverter. Now let's make the circuit required for this project. So guys, our circuit is now complete. Here we have 4 IGBT switches, that is insulated gate bipolar junction transistor switches. We have a DC voltage source, and we can see that a resistance of 10 ohm is connected as a load. Here the IGBT switches are connected in bridge fashion as shown. To visualize the current, we have current measurement, and to visualize the voltage, we have the voltage measurement. Here both current and voltage are connected to the scope to visualize them properly. Now guys, for our inverter circuit, we need an input. We will take pulse generator as an input. So let's quickly connect the circuit about this pulse generator and see the output of our inverter. So guys, we have added our pulse generators in our inverter circuit. Here, pulse generator 1 has the amplitude of 1, time period of 0.02 second and the phase delay of 0 second, while the pulse generator 2 has the same constraints but it has the phase delay of 0.01 second. That is, when pulse generator 1 is high, during this condition the pulse generator 2 is low. We can visualize it through the scope. Before running into output section, we need to make sure that switch 1 and switch 3 operate simultaneously, and same goes for switch 2 and 4. We need to make sure that switch 1 and 2 or switch 3 and 4 must not occur simultaneously. For this, we have used 2 pulse generators and provided the phase delay as shown in the graph. Now let's get into the output of this project. Here in the graph, the output of this inverter is seen. The upper portion of the graph shows the current while the lower portion shows the voltage. Here we can see that the constant supply was given to the inverter through the pulse generators, and we have obtained the alternating current. Here alternating current doesn't mean the current and voltage is sinusoidal. It means that it is alternating between the positive maximum and the negative maximum as shown in the given graph. Now to make our output sinusoidal or almost sinusoidal, we are going to use LC filter. So let's quickly do that. So we have applied our LC filter to this circuit. Here the inductor of 8 mH is used, and that of capacitor of capacitance 30 microfarad is used. Here the capacitor is grounded as shown in the circuit, and we can see the output of our inverter. The output is almost sinusoidal in nature. Now guys, let's apply the zero order hold to see the animation of our inverter signal. So guys, we have applied our zero order hold and we can see the animation going on. Here the sampling time has been decreased so that we can absorb the signal. So guys, this was our single phase inverter project. Thank you.